Hello students, welcome back to lecture 6 of Arrays chapter. The last class we discussed binary search, the mechanism, how it works, the logic used in binary search, and we have seen an example, a program in BlueJ where binary search was applied on a set of integers. Fine. So in today's class, we will see how binary search is applied on a set of string type elements. When you are given the numbers in ascending order, where the names are arranged in alphabetical order, A to Z or Z to A, then how to apply binary search for searching a particular element from the set of string elements in a string array. Okay, so let me take you directly to BlueJ screen where I'll explain you the program directly there. Okay, just give me a few seconds. Yeah, so here just go through the program. It's write a program to input names of 5 captains of Indian cricket team. Okay, I have just changed the question. So it's actually create a string array with 5 cricketers' name, the captains of Indian cricket team. Okay, so basically you have to create a string array containing the names of 5 captains of Indian cricket team. Right, in alphabetical order. So it is in A to Z, that is alphabetical order, like how we store names in attendance register of the school, starting from A till Z. That is called increasing order or ascending order of names. Now, using binary search, we have to print the position of the name selected or accepted by the user for searching. Okay, so it is similar to what we have done last class, but now the elements are of type string. Okay, so there are few changes, and otherwise the binary search logic remains same. So generally binary search is given with initialized elements like this. So I thought I'll give you one example where elements are initialized directly into the array. So if you have to initialize elements, please do it like this. It depends on the question. In the question, if they have given the elements to be initialized, you have to directly initialize. In such case, no need to accept data from the user. You can directly initialize. So when you initialize the elements directly, we do not create an array and we do not input elements into the array, because here we are directly initializing the elements. Okay. Now, so since elements are initialized, we directly write this here. This is array declaration. Now the elements are of type string. So here the data type of the array is string. The name of array is n. Since it contains names, I gave the name of the array as n. So this part is array declaration, followed by the elements of the array. So I have given 5 names of the captains of Indian cricket team. Okay. Now, as we have seen in previous program also, the variables which we use in binary search, flag for printing the error message, we make use of flag variable. And in binary search, we use these 3 variables: L, which stores the first index, that is 0, R, that stores the last index. In general, it is n.length -1, and M for storing the mid index. Okay, so you declare the variables, and this part I have just written for displaying the elements, like in order to see the elements on terminal window. I have written it, but this is not necessary to write in your program. Okay, this is just for convenience sake I have written it. You can skip writing it in your program. Now here, this is enter an array element to be searched. So here you will accept an element to be searched, right? And then starts the binary search process starting from here. Okay, just a minute. I'll just show you the difference. This is not necessary. I'm putting it in a multi-line comment. Yeah, so now this is not part of the program. So here you initialize the array, then declare the variables used in binary search. Okay, and then here you accept the array element to be searched. Okay. Okay, and then starts your binary search process. You can see almost everything is same except for the comparison part. Okay, so if you have any doubts with binary search, please listen this carefully and you can clarify your previous doubts in case you have. Now here, this will be the condition while L less than equal to R. L is 0 and R is the last index. Here, the number of elements are 5. So the R will be your 4, A dot length minus 1. So always your left L will be less than equal to right. So we use that as a condition for while loop. And then we calculate M, L plus R by 2, put L and R in brackets. Now here we want to compare the name with, the name is what we are searching for. We are storing it in a variable name and we compare name with the element at mid position. Now since both these contain string constant, we cannot use double equal for comparing n of m and the name, right? Now here both of these are string type, right? They contain a string constant and string constant cannot be compared using relational operator equal to. Therefore, we have to use string functions for comparing string. So you can use here, instead of this, you can use equal. You can use equals function for comparing these two, or you can even use compare to. So if you are using compare to, then you have to equate it with 0 because you know that if two strings are same, then compare to returns 0, right? So name dot compare to n of m equal to 0. So when the compiler compares these two, n of m and name, it will compare it with respect to their ASCII and it returns an integer value. So if this returns an integer 0 and 0 equals 0, this will be true. That means both name and n of m are exactly same. See, if requires a condition that returns true or false. Therefore, we have to equate it to 0. If you do not write this part, then it will return some integer. And if requires a Boolean value as an output of the condition. Therefore, you have to equate it with 0 so that your answer is in terms of Boolean value. Fine? Yes. So if this is true, that means name and n of m are matching. They are exactly same. Hence, you found the name in the array n of n and therefore you got the position of name in m plus 1. You make flag 1 and you come out of the while loop using a break statement, right? But if this is not the case, then the other two conditions arise. That is, if name is greater than n of m, if your name which you are searching is to the right of n of m, right? Then what we do, we shift L to m plus 1. And if name is less than n of m, if name with respect to its alphabetical order, if it is less than n of m, then we shift. That means what? It is to the left of n of m, and therefore we shift r to m minus 1. So do not get confused as we are using strings. Whenever you get a doubt in these two places, just visualize an array of integers also, not an issue. Both in integers as well as in strings, these two conditions remain same. This is something like name greater than n of m, right? This is same as that, but we just replace this with compareTo. So name greater than n of m, that's what you are checking. That means you're checking if your name is to the right side of n of m. So we bring L to m plus 1. Okay. So you can visualize an integer array and frame this condition if you are confused with string. It remains same. Fine. So with this, your L and R value will change, and again the control will go back to while. Again your m will be calculated, and these comparisons will continue unless and until this condition becomes true at one point, giving you the position of the element, provided the element is in the list. Otherwise, your flag will remain 0, and which you will use for printing the error message. Okay, so please do it in BlueJ, and also try for elements in descending order. You can have names in descending order, that is Z to A, and in that case these two conditions will change. All other things will remain same, only this will change. Okay, you want to check, like if the elements are in descending order, for example zebra, x-ray, apple, this way. Now if name dot compare to n of m greater than 0, if your name is greater than n of m, if the elements are in descending order, suppose if the elements are in descending order and the name which you are searching is greater than n of m, greater than n of m. So if the array is in descending order, your name is to the right or left of n of mid. Yes, because it is descending order, the name which you are searching is to the left of m. Therefore, r will be shifted to m minus 1. R will be shifted to m minus 1. And similarly, if your name is less than n of m, that means if your name is lesser than the element at mid position. Yes, because it is descending order, the element which you are searching, because it is less than n of m, it is to the right side of n of m. Therefore, your L will be changed to m plus 1. Right? So these two conditions will take place if the array is in descending order, both in case of integers as well as in strings. Only just to be clear with the logic. If you get confused, you can visualize an integer array and frame these conditions. The only difference is, instead of the relational operator equal to, we will make use of compareTo function. And how to use? Very simple. It is like if you want to compare name is equal to n of m, we do it like this. And when you want to check name greater than n of m, we do it like this with same meaning. Similarly this. So just remember to use compareTo when you are dealing with string arrays. Otherwise, your relational operator equal to will be used for comparing the integer type values. Okay, so this is your linear search logic. And finally, if your flag remains 0, you will print search unsuccessful element not in the list. Okay, so this is your binary search application on string type of element. Okay, let me show you the output for this. Let me compile. Okay. Now, if you just see these names here, Azar, Dhoni, Sachin, Sunil, and Kohli. Now, if I give Sunil as the element to be searched, it should display the position of the element as 4. Okay. Because in the output, you will not see the elements. Therefore, just concentrate on this. It is compiled. No syntax error. Now I close this and right click to see the output. Click on main. Yeah, enter an array element to be searched. Yeah, so I'll give, I think I gave it as S capital because it is Java is case sensitive. If I give, one second, if I'm not sure, I think Dhoni I gave in D capital. Yes, so element Dhoni found at position 2. Yes. Now, if you want to see the elements, okay, that's it. And now I'll just show you. Enter an element to be searched. See, suppose I give the name as Dhoni. Now, what will it do? Yeah, because Java is case sensitive, so it is not matching with the names in the list. There, D is capital. That's why it is not doing it. Or you have to give there equals ignore case. Shall we check that? Okay, name dot compare to n of m. If I give your name dot equals ignore case instead of compare to, then it will consider the cases also. See, for this first condition, you can use that. But for the other two conditions, you cannot use equals or equals ignore case. But for the first one, since you're comparing name and n of m for equality, you can use equals or equals ignore case or compare to. Okay, it is done. Now, right click, main. Now, I'll give Dhoni again in small case. Oh, element not in the list. Okay, fine. So do not get confused. Equals ignore case. Okay, let it remain compared to only. Control Y. Okay, fine. I think this is clear. Java is case sensitive, so take care of the sign and the lowercase and uppercase thing. And practice doing these programs, the binary search on integer type of data and binary search on string type of data. The only difference is when you compare strings, you have to use string functions for comparison. And for all other data type, you can use relational operator equals, equal to for comparing, right? So with this, we come to end of today's class. Please practice these in BlueJ, and then we'll have some theory type questions next class. Before we start, the next algorithm, that is sorting. We have bubble sort in our syllabus, which is very interesting and important. Okay, so this much only for today's class. Keep practicing. Thank you, everyone. Bye.